second, but we're going to move forward. So today we're talking about graphing sine and cosine functions. So some of you might have seen the sine wave or the cosine wave at some point. Maybe not though. But we're going to learn to graph them today. We also, and this probably is not a huge surprise, we're going to look at, we have our sine wave and our cosine wave, but we're going to look at what happens when we stretch, when we shrink it, when we translate it up, down, forward, backward, all that kind of stuff. So we're going to do our best to give, it's not a super easy lesson. So if you start to zone out, then we got to stick with it. But it's also not something that's like we're never going to get it. Okay, a lot of the stuff that we're talking about today, we've seen in other contexts, like this idea of stretching, shrinking, of translating our graph up or down. We've done a lot of that before, but we are not used to working with a graph that's like a wave and fluid like that. So it is a little bit difficult. Now, when we look at the sine function, again, we have a sine wave. It continues forever and ever with that same wave. If you guys would have filled out the negative side of the chart, you would have seen a lot of values that looked, just like this. Now, this doesn't go point for point with your chart, but when you see these values on the chart that you just filled out, when you see 0, you should have 0, 0. You should have pi over 2, 1, pi 0, and all of those. Does our chart check out with those points? I know you had more points on your positive side of the chart, but does our chart check out for those? Okay. A couple of things we're going to look at the sine wave first, and then we'll look at the cosine wave. A couple of things to point out with the sine wave. A lot of times we don't graph this negative side of the waves. We just want to graph one portion of it, and a lot of times we'll start out here right at the y-axis. So notice that with the parent function of the sine wave, it starts out right at the origin, right at 0, 0. So as long as we don't have something where we're adding, subtracting, and shifting our wave, and we'll get to that, we can start by graphing our sine wave with the first point at 0, 0. Okay? Now, like it says on here, and we will go over these terms a little bit more, but one of the terms that we'll learn is that we have a period of the sine wave. And all that the period means is that the whole wave repeats this section. If you take from 0 to 2 pi, it will keep repeating that same thing all throughout. You can see it'll just keep going forever and ever and repeating that section. So that section that is continuously being repeated is called the period. And that, with our parent function, is the length of 2 pi. Okay, questions about that? Again, we're going to go over this term again, but I'm just going to introduce it a little bit now. Now, like you can see, our maximum value with the parent function of the sine wave is all the way up at 1. The minimum value is down at -1. Now, if we know that a period, or the part of the sine wave that is always repeating, if it's just from 0 to 2 pi, we know it's 2 pi long. You guys tell me, what do you notice about the location of the maximum? Like, how far into the period is it? Pi over 2. So we know that pi out of, and I'm trying to work towards something, you'll see it in a second. If our period is 2 pi long, if we know that pi is half, then pi over 2 would be what, fraction-wise? If we're pi over 2, if pi is half, then it would be 1/4. So we should see with a typical sine wave, our maximum is 1/4 of the way through. And we will come back to that, and we will be using that and get used to that. What do we notice about our minimum? How far into our sine wave is that? 3/4, yeah, of the whole period. but it would be, in this case, at the point 3 pi over 2. Yep, you both are on the right track. So we know that it is 3/4. The minimum of our parent function sine wave is 3/4 of the way through. Okay, good. Now, last one. What about the x-intercept? How far through our 2 pi sine wave is that? It's right at half. Yep, it's right at pi. Okay? So, just a couple things to point out. If I were you sketching notes, whoopsies. I have paper for you to sketch your sine wave on. You want... That's how my fault. I meant to get that to you before I started writing down the front. So why don't you guys, if you've got the slides in front of you, start sketching in that sine wave. Also, what? Oh, sorry. I mean, you don't have to use the piece of paper. I'm not going to collect anything.
How do you know it's like 1/4, 1/2, 3/4?
How do we know?
Yeah.
Well, I mean, how do I know for sure that this is 1/4 right here?
Yeah.
Well, it's...
Well, like, I guess you just say that it's 1/4, 1/2.
Well, part of it, yes. I'm telling you that when we have our parent function sine wave, if like we aren't stretching this or shrinking it or anything like that, then the maximum will be 1/4 of the way through the entire wave. Okay, we'll go through some examples and you'll get it a lot more. What I would do to graph, I would look at that sine or that top part. Your top fraction. Make sure you're on the side that has the pi's on it, not on the degrees side. Make sure you're on the side that has all the pi's on it, not the degrees side. We're graphing our sine wave. I would use these points right here. I would plot those points on your sine wave and then just sketch in the wave after plotting those 6 points or 8 points. So you can go to x at -2 is the far left, 0, put a point. -3 pi over 2, 1, put a point, and so on. So like this. Don't get all caught up on the 1/4. Don't get too caught up on that. -5 over or -2 pi, put 0. And then keep moving through, plot those points, and just sketching the wave. There. Well, 1 on this is all the way here. They try to spread out. Yeah, 1 is all the way at the top, just in case you guys didn't catch that. And if yours is the same as the person next to you. So on this, I mean, you can kind of see it. 1 is all the way at the top. So if you want to stretch a little bit, like this is, if you just put 1, I would just put 1 right there, and that's okay. I was gonna say what.
You were showing me such an angle.
Hey, Trey is focusing on graphing his sine wave. So is Annie. So is whoever else is watching. No distracting. No, she's not. You can see her.
Wait, do we have to do all of them?
Well, you just need to graph the sine wave to start out. And then I would write a couple notes about our 1/4, 1/2, 3/4. All right, let's keep moving. So now we have our cosine function, or our cosine wave. Now notice, sine started at 0, 0. Cosine starts, if we look right at the y-axis, starts at 0, 1. Yep. So that's a big tell for how we can know if we're looking at a sine wave or a cosine wave. Is are we starting here and moving up, or are we starting at 0, 0 and moving from there? Go ahead, take a second on that next spot and sketch in the cosine wave using these points. Are we good with that cosine function? I'm not going to talk about, I mean, you can see the period or the section that is repeated with the cosine function is still 2 pi. We will talk about amplitude. We'll talk about that stuff in a second. And I'll give a better definition of period in a second. Back row, are you guys still sketching? Okay. We'll go 10 more seconds. All right. So there are our two sine and cosine waves. Now, let's look at characteristics, and this applies to both of them, okay? We talked about, well, we didn't talk about amplitude. I mentioned amplitude. So the amplitude of the graph of each function is half the distance of the maximum and minimum. So don't let that freak you out. If we look at our cosine, or if we look at our sine function, the amplitude is half the distance from the minimum to the maximum. So that would just be what value from the midline to the maximum? It would just be 1, right? Now the way that it's not always going to be 1. A lot of times it will be. But if we write half of the difference of the max and the min, that would be 1/2 times the max minus the minimum. So we would get 1. I mean, it's easy to look at the graph and see, okay, our amplitude is 1 from that graph. But other times it might not be quite so easy. Now the period we talked about, but I'll read through this again. Each function is periodic, which means that its graph has a repeating pattern, right? We talked about that. The period is that section that is repeated. We would consider these both to be a periodic graph. The shortest repeating cycle portion of the graph is called a cycle. So on here, when I scribbled everything else out and looked at just this section from 0 to 2 pi, this would be considered a cycle. And this is not like notes that you have to hurry up and to write down. This is just when we're talking about the sine and cosine wave, this is the vocabulary that you'll see in problem directions and hopefully my vocab, all that kind of stuff. The horizontal length of each cycle is called the period. So again, we would call this our cycle, and we would call 2 pi specifically the length of that cycle is called the period. So cycle and period are very, very similar to each other. A couple other notes to pay attention to. The domain, hopefully this is not a surprise, is all real numbers because it just keeps going forever and ever, right? It'll have all x values in both directions. Our range of the parent functions is from -1 to 1. Hopefully that's pretty obvious too with both of those. Now, like you can see, and our x-intercepts for the sine wave. So for our top one, it intercepts at 0, at pi, at 2 pi, and it will continue to go in both the positive and the negative direction. And we kind of talked about those intercepts a little bit. And those would be, for a parent function, the x-intercepts for the cosine function. A couple more terms, and then we'll look at examples and kind of put it all together. When we have, will you take sine for example? When we have some number in front of the sine, that would be what either stretches us or shrinks us. Sorry, I went horizontal. Stretches or shrinks along the vertical axis, so across the y-intercept. And that number is legit. Just like what is away from x, like we talked about earlier, right? X always lies, y is for real, or y is legit. What is away from the x in this case, what is outside of the sine, is for real. If it says that we are multiplying by 4, then we have a vertical stretch of 4. What is happening directly to the x when we're talking about multiplying? That is what stretches us horizontally. And like always, if it says we're multiplying by 6, we really have a horizontal stretch of 1/6. So x is lying again. What is happening inside the sine is lying. How are we doing so far? Okay, that's fair. There we go. We talked about amplitude already. Right, the amplitude is just how far we're going from really the midline of that wave to the top, or that midline to the minimum there. When we look at our equation, when they give us an equation, if they don't give us a graph, we can see what the amplitude is by taking the absolute value of whatever is outside of the sine or outside of the cosine. So in that previous, I had 4 sine. We would have the amplitude. We would say that A equals the absolute value of 4, or just 4. Our amplitude is 4. That means that this is our x, this is our y, that our wave is going up 4, down 4, up 4, down 4, up 4, down 4, right? That's what our amplitude is talking about. It's how far from that midline we are. Now the period, how long that pattern is repeating for, is found by taking the absolute value of what is happening inside of our sine or cosine. Okay, the normal period is pi over 2. So that's why we are taking whatever is happening inside our sine or cosine and dividing by what that x is being multiplied by. Now, I just threw a lot of new information. We probably are a little bit overwhelmed, right? Yes. Emma's like, yeah, definitely. We'll look at some examples. I put a lot out there. We're going to look at a couple of examples, and we'll be okay. So first, with this first example, identify the amplitude and the period of, I already used one with 4, but that's okay, of g of x equals 4 sine of x. Now remember, we talked about this amplitude is the number that's in front of our sine or cosine. So identify the amplitude, we already know it's 4. We didn't even have to do any math for that. Now, when we are finding the period, remember, the normal period of our sine and cosine functions, like you see on the left screen, is how long? How long is the normal period? How long is it? 2 pi. So we take 2 pi to find the period of this equation. We take 2 pi and divide it by whatever number is being multiplied by x. Well, what is being multiplied by x right now? Just 1. Yep, so our period is 2 pi. Now, if we have to graph this function, does the sine function start when we're talking about at the y-axis for the start? Does it start at 0 or start up at 1? It starts down at 0. Yep. So we have our first point. Well, our parent function here, really when we graph these, we graph like from here over most of the time. So our parent function starts at 0. And since we aren't adding or subtracting, and we'll get to that eventually, but not here. We're not adding or subtracting anything from the x. We're not moving up or down, or left or right, excuse me. So we can still start at 0, 0. Now, when we graph these, there are important points that we need to make sure are on our graph. We need to have our minimum and maximum, and then our x-intercepts. Okay, or x-intercept if there's only one. Now, if we are looking at our maximum, what is the y value? How far up are we going to go from 0, 0? 4. And how do you know that? Because it's in front of Sine. Right, 4 is our amplitude, so that means that we are going up 4 from the x-axis, coming back to the x-axis, and we'll go down 4. So we know that our maximum is at 4. Now, we know this whole thing is cycling 2 pi, so we need to just graph it inside of 2 pi. So that would mean pi is like here. We'll say pi over 2 is like right here. Now, how are we going to figure out what the x value of our maximum is? How are we going to find that? Perfect. Like we talked about earlier, our maximum happens with our sine at 1/4 of the whole period, right? Now, in this case, our period is 2 pi. That's the case for our parent function. So we can see at pi over 2, that's where our maximum is happening. So if we were writing that point for the max, we would have pi over 2, 4. So we can plot that point in right there. Now what about, let's go with our minimum as well. Where's our minimum at? Yep, so the y value is -4, good. What about the x value? How far are we going? At 3 pi over 2. Yep, it's happening 3/4 of the way through our whole period. Good. So that would be down here. Oh, yes, sorry. 3/4 of the way through 3 pi over 2. That kind of rhymed. I could come up with something for that. Now, what do we still need to graph? Well, we need to know where our intercepts are at. What? How do you know that? We know with our sine wave, the x-intercept is halfway through our period. We also know it ends at an x-intercept as well. So when we're sketching all of this, we can connect those and sketch it through. Why don't we, I'll give you your homework. I've got more examples, and we'll go through those. But I will let you do the first 3 on your homework. You should be good to do the first 3. You haven't looked at an example of cosine yet. Now the cosine is a little different with our 1/4 that we looked at, our 1/2, yes, but you can take a look at cosine if you would like.
No ball.
So for the first two, all you need to do is identify the amplitude and the period of the graph. Hey, no cheating. Did I say that? I don't know if I said that. Did you just quote me like word for word?
Yeah.
Well, that's pretty good.
You do listen. So look, where the max is of that, let's see, that's 1/2. Now we get one, and then we get one. So our amplitude is just 0.5. Well, now we need to look at the second one. This.
Stick like glue.
2. And it doesn't give me blue. This is now at -2. So we're in the midline. Now this wants, I think, and here. How long is that? Good. Yeah. So I feel like passing drops. What? Right, so, well, that's what we're looking at already. So, if you look at this graph, you can see that it starts here, loops, and now it's back to where it started. So that would be the start to kind of finish. Now, if they don't label it here, I'm not sure why, but we have pi, 2 pi, 3 pi, and 3 pi. So after this, we just keep repeating the same thing we see the other way and the other way. Every 4 pi. From what? It's a little bit difficult to see for upscale. That was very good. I can see what I wrote down. Well, when we talk about how we find period, it's 2 pi over 6, right? Like in that. Right. Yep, we consider that a B. Yep. The period of that one? Well, I mean, in a normal graph, you'd hope that it's labeled good enough that you can just see it.
I think it's 4.
I wrote down 4.
Because 2's halfway.
Yeah, I wrote down 4. Yeah, that's another good way. See what's halfway? Yep.
Are we done learning?
Are we done learning? I would like to look at one more thing, but we may not. Make sure you graph those two. You can give a try to number 4 is the cosine graph. There's a couple different rules that you give a try. So at 3 pi, we look at what our period is. This is our start, right? We go all the way back through. So really up here is
Chase is like, oh, I get it.
now I know it's not labeled. I don't know why they didn't extend this a little bit. But like, you know what I mean? I don't know why they did
No, he's laughing.
Look at the cycle. Which you did here. You start all the way up at 2.
I just didn't know
What that meant. Remember, the period is 5 things are the way. Period is just talking about the year. Start. End at the same level. So here we start high and start at 0 and end at 0. How long? Horizontal. So here's pi.
Yeah, how do you do that?
Here's 3 pi. This would be up to 4 pi. So that Yeah, or let's see, that's at 2. So I think that's trying to get at 4. But again, that's not maybe. Hey, what are you doing on your phone? Did you guys try? You guys didn't even do these.
Yes, we did.
No,
1
you
and
didn't.
2.
You can do. I said do number 3.
My bad.
Alright, let's see.
Now, when you look at, you guys should be able to do number 1, 2, and 3. I know it's a lot, but I think you guys are getting it. You can also do number 5. Yep, this is true. We have not talked about, you could do the cosine stuff. We just haven't talked about, what's wrong with cosine? Oh.
Can we just like look it up on our graph?
No.
That's actually smart.
Yeah.
Oh my gosh.
You know what that is. Yes.
I don't know how to put it in the calculator.
That's even
Yeah, sure.
I actually don't know how to define it. I know how to get the F from the period, but
You know how to graph it. You know how high it's going up. Now our period is only pi, right? So we're used to 2 pi. It's only pi, so it's going to be a quicker.
so it's just gonna be up like that.
Well, it's going to go up, down, and back up. I can go over in a second. I want to do one cosine problem, so then you guys are able to do the most of it. You won't be able to do 9 through 12 yet, but that will not take a whole lot.
Doesn't that just move it?
It does. It just moves it left and right. So that's probably what we would do tomorrow.
That's not that hard.
All right. I'm going to do number 4 on your homework. Okay, and then that'll be all the learning we have for today. Tomorrow we will learn a phase shift, and that will move us left and right. So, if we look at number 4, we have g of x equals 4 cosine of x. What do we already know that the amplitude is?
4.
Good. What about the period?
1. Or 2 pi.
2 pi divided by 1, so our period would be 2 pi. Now, we are dealing with a cosine wave this time. So does the cosine wave start up or start down? It starts high, so it starts at the top, 1, 2, 3, 4, at the top of our amplitude. Now, we know the wave is going for 2 pi, so that's what we need to graph. It is kind of interesting. Now, we need to be careful because our same kind of fractions that we got used to earlier don't necessarily apply here. When we look at our sine wave, we knew our x-intercept was halfway through. When we look at our cosine wave, what do we see halfway through the period?
Minimum.
We have our minimum value. Yep. So in this case, our we still have a period of 2 pi, right? So it mimics that parent function a lot. But what is the y value going to be at pi? If we have pi, yep, our minimum is -4. That's a good question. At 2 pi, now what we're starting to understand with when we graph a period, we need to start and finish at the same height. Okay? We'll start and finish at the same height. So we can start to just put these points in and kind of build our graph. What else are we missing? We have where we start, we have where we end, we have the minimum.
You need the max and intercept.
Well, these are the maximum. Well, we don't have it sketched in, really. We need our x-intercepts, which Faith said, and we all heard, but Cole whispered as well. Nice job, Cole. Now, when you look at that parent function, how far into that cosine graph? Hi, Mrs. Shue. Yes. Yep, planning on it. These guys are getting a little amplitude and all that good stuff.
Wonderful.
I was hoping to hit phase shift today, but I think that's going to be a Flex Friday event. I'm moving it. You're not at all? Oh, we're not doing that tomorrow, that's for sure.
Let's go.
Yeah. That's huge because I did not want to teach
All you
phase
gotta
shift.
remember is gotta do the line on
Something. What?
You last man to get something.
He's kind of good at that. Okay, we got to finish this problem. So, yeah, we do. That's huge, though, that they're not doing phase shift. That means we don't need to worry about the back side of this paper. That's really nice. Okay. Hey, we still need to put our x-intercepts on. How far into that cosine, if we look at our cosine parent function, how far into it is our x-intercept? At pi over 2. Good. So we can go to pi over 2 because we have the same period.
Let's go.
How about the next x-intercept?
3 pi over 2.
You guys are so smart.
Now, you tell me, I've said it a few times. Why can we just put the same x-intercepts as our parent function with this problem? Why? Use the vocab that we've talked about. Why? Because it's the same amplitude. Yes. Oh, just kidding. No, not amplitude. It's the same period, right? It's repeating itself all in 2 pi. So we can, sorry, Annie, sorry. That's all right. You send me nice emails, right? You're very polite. Ask how my day was, all that good stuff. So it's okay. So we can sketch in our graph. Virtual students, hopefully you fast forward a lot, but you made it to the end. Good job.